Question is, an electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, its resistance at room temperature, that is 27 degrees Celsius, is found to be 75.3 ohm. When the toaster is connected to a 230 volt supply, the current settles after a few seconds to a steady value of 2.68 ampere. What is the steady temperature of the nichrome element? The temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.70 into 10 raised to minus 4 per degree Celsius. So in the question, the given element is a nichrome. That is, an electric toaster is given there which uses nichrome for heating, and at a room temperature the resistance of the nichrome wire is given as 75.3 ohm. Then the toaster is connected to a 230 volt supply. Then a current of 2.68 ampere is flowing through it. We know when current flows through a conductor, heating effects come into play and some of the energy is lost as heat energy. As a result, the conductor is heated up. One more thing we know, that is the temperature dependence of resistance. That is, when the temperature increases, the resistance also will get increased. For nichrome, this resistance is very small scale, but here it is asked to find out, so let us calculate it. That is, what is the new resistance when temperature is increased due to the current flow. So let us take the equation for temperature dependence of the resistance, that is RT is equal to R0 into 1 plus alpha into T minus T0, where RT is the the resistance at a temperature T, and T0 is a reference temperature, R0 is resistance at the reference temperature, alpha is temperature coefficients of resistance. In the given question, let us take room temperature as the reference temperature, and that is T0 is equal to 27 degrees Celsius. The resistance of the material at room temperature is taken as R0, that is resistance at a reference temperature R0 is equal to, it is given in the question as 75.3 ohm. Temperature coefficient of resistance alpha also given in the question as 1.7 into 10 raised to minus 4 per degree Celsius. So we are asked to find out the temperature when current is flowing. Therefore, first we have to find out the resistance RT when the current is flowing. Here the voltage and current both are given there. Voltage V is equal to 230 volt and current I is equal to 2.68 ampere. Therefore, when current is flowing, the resistance of the material RT is find out using Ohm's law. V by I is equal to 230 divided by 2.68 equal to, we will get 85.8 ohm. So substituting all these values in equation 1, we can find out the temperature T when the current flows through the material. So let us substitute all the values there. RT we obtained there as 85.8 ohm. R0 is the resistance at room temperature 75.3 ohm into 1 plus the value of alpha is 1.7 into 10 raised to minus 4 into T minus T0. We know the value of T0, it is room temperature 27 degrees Celsius, but let us put the value in the final step after simplifying all the steps. So let us multiply this 75.3 with each and every term within the bracket. Let us write 75.3 into 1 is 75.3 plus 75.3 into 1.7 into 10 raised to minus 4 into t minus t0. Next, let us put 75.3 into LHS. It will become negative sign. Therefore, 85.8 minus 75.3 is equal to 75.3 into 1.7 into 10 raised to minus 4 into t minus t0. Then bring this bracket term into LHS. We will get an equation for t minus t0 as t minus t0 is equal to 85.8 minus 75.3 divided by 75.3 into 1.7 into 10 raised to minus 4 equal to 820 degrees Celsius we will get. Therefore, T is equal to 820 plus T0. T0 we know the reference temperature 27 degrees Celsius. Therefore, 820 plus 27 is equal to 847 degree Celsius.